Hey, welcome back, everyone. This is going to be the University of Illinois Cybersecurity CTF. We're going to be covering fair evasion. It's a web challenge. Just before we jump into things, I do have a blog here with a visual workflow summary where you can see how this challenge is solved at a high level visually. Also have a summary, a technical summary, references, and then I get into the challenge in the bits and pieces of it. But let's go ahead and take a look at our challenge. It reads, the SIG Pony Transit Authority needs your fares, but the system is acting a tad odd. We'll let you sign your tickets this time. Let's go ahead and take a look at the website. Here's the website, not a whole lot going on. 2 buttons, one is commented out. That's the I'm a conductor, or sorry, not commented out, it's grayed out. There is no front-end functionality there.
Deception and double deception.
If we click I'm a passenger, you see we get this message, transaction failed, where's your token? Let's go ahead and inspect the website source. The key pieces of information for this challenge were contained here in the index.html file. You can see that we have the pay function, and then commented out it reads, I could not get SQLite to work on the front end. Below that, you can see the SQL query where, interestingly so, there is an MD5 hash of this KID header. The KID is a key identifier. And below this, you can see that it is, of course, a post request. And below this, there's another comment that says convert MD5 to hex string instead of Latin 1. Okay, interesting. Let's go ahead and burp the request and see what we get. All right, here we are ready to burp the request. But before we do, let's click I'm a passenger again. And we get an error or a message this time saying, sorry, passenger, only conductors are allowed. Please sign your own tickets. And below this, you can see that there's a secret. So it actually gives us a secret. Boring passenger key. Then these characters here, I think this is the Latin one. This is like the string that was commented out saying it needed to be converted from MD5 to hex. But let's go ahead and intercept this request. And what we get here is a access token up here. So this is, of course, the JWT, the Java Web Token in this challenge. We'll send this over to Repeater where we can send this off and see that we get the same response back. Let's go ahead and copy this access token and jump over to a Java Web Token editor and see what it reads. Here we are looking at the JWT token, and I know here the header, it actually has the KID, the key identify header here. However, when I did this challenge, this was not present, so I'm not sure what's going on. I had to actually add this. However,
moving on.
What matters here is we need to sign our own key. That's been suggested to us through the challenge description and the prompt we're getting in the top right. So we need to somehow find a secret to sign this. And you might think maybe it's the passenger key. You would try that. It is not the passenger key. So what we're going to do is a little bit of research here. Let me show you an article about some SQL injection. Just quickly before we do that, I actually want to show what the error message is when you don't have the KID header. So if we remove the KID header, maybe this is, I don't know, I'm on a incognito browser, so I'm not sure why this is doing this. Maybe the authors updated the challenge and I wasn't aware. But if we get rid of that KID header and actually copy this access token and send it off, you'll see we get a message saying you lost your KID on the train. And this is how I learned about the KID header, which I just refer to as the key identifier. It's just their key IDs in the back, like unique IDs. And it says here success false. So there's clearly an authentication check. It's checking for something, but this was the hint. So I did some research into the KID header and the KID SQL injection, which initially, although it's not the right path, it brought me over here. On the Hatrix page under SQL injection, they actually have a specific area for the KID issues. And there's one for SQL injection here. And I played around with that for a bit and nothing came of it. So the path we have to take is actually the path of a MD5 SQL injection attack. Let me show you. So you can see here on the Hatrix page that this raw hash authentication bypass, if we look at how it's structured, it is actually the same as what was commented out on the index.html page, the main page of the Fair Evasion Challenge. And we have that MD5 variable right here. Now, there is, I believe this was first uncovered in 2010. There's a link in my blog, and I'll put it down below, just about who I think are the original authors, the CTF team that uncovered this. But the whole premise, the whole thing is because whatever query you pass to the backend SQL server is being hashed, they endeavor to successfully find a SQL injection string that was short enough, when it was hashed with MD5, it would actually provide a proper string size as the output, and it would be processed in the backend on the server. If you actually did the challenge and discovered that on the fly, good for you. That's amazing. However, some savvy research would have also led you here to this kind of classic problem. But you can see here, jumping right into the payload, FIFI DOP is the actual payload that will cause some issues on the server. So we're actually just going to copy this and build this into our JWT token and send that. Let me show you. Okay, so you can see here that I've added the KID header with the FIFI DOP payload, whatever you want to call it. Let's go ahead and copy this and put this in our burp request and see what the response is from the server. All right, here it is, drum roll. I'm going to send off this request, and here we go. We get a similar response initially, but then we see this new string down here where the conductor key is actually revealed. So this is our signing key. So we're going to go ahead and copy this, and we're going to paste this into our JWT token editor, and this is going to be the signing key. We're going to paste it right there. We're going to copy this new access token, pop it in, send it. Oh, let's try that again. I always forget, you have to actually remove the preamble of the signature here. So let's try this again. Now be our flag. And there it is, conductor over.